Hey there and welcome. Look, I know building an AI agent can seem, a little intimidating, but today we're not going to treat this like some dry lecture. Nope. We're going to frame it as a journey. It's an adventure, really, taking a simple piece of code and turning it into this powerful collaborative system that's ready for the real world. So, you ready? Let's jump right in.
All right, so here's our roadmap for today. We're going to start with the absolute basics in Chapter 1. Then, we'll give our agent some cool tools. After that, we'll give it a memory. Then, and this is super important, we'll figure out how to see what it's thinking. And finally, we'll set it loose out in the wild. Simple as that. All right, Chapter 1, building your first agent. It's all about laying the foundation. You've got to start somewhere, right? We're going to break down the absolute fundamental pieces that make up any AI agent out there.
So what are we actually talking about when we say agent? Let's meet the main character of our story. At its core, an agent is an AI that's powered by a large language model. That's the brain, the part that does all the reasoning. It follows your instructions, sure, but the really important part is that it can use tools to actually accomplish tasks in the real world. It's a doer, not just a thinker. And what I absolutely love about this is how simple it is at the start. Every single agent, no matter how complicated it gets later, boils down to these three things. You've got the model, that's the brain, the reasoning engine like Gemini. Then you've got the instruction. Think of this as its job description, its whole persona and goal in life. And finally, you have the tools. These are its hands and feet, the actual functions it can use to do stuff. That's it. This is the simple trio that everything else is going to be built on.
Okay, Chapter 2, giving your agent tools. Because right now, our agent has a brain and a mission, but it's kind of just stuck in a box. It can't really do anything. So it's time to install the tools it needs to tackle some really complex jobs and interact with the world around it.
Now, let's talk about a huge shortcut. This is a real game changer. Normally, you'd have to write tons of custom code to connect to, say, GitHub or Slack or a database. But with the Model Context Protocol, or MCP, you don't have to. Just think of it like a universal power adapter. It's this open standard that lets your agent plug into a whole universe of community-built tools, like instantly. It's amazing.
And getting this to work is, well, it's surprisingly simple. Seriously. You just pick an MCP server that has the tools you want. You configure the connection with a tiny bit of code. You tell your agent, hey, here are your new tools. And that's it. You run it, and suddenly your agent has all these new superpowers, and you barely had to write any code to make it happen. No wrestling with APIs. It just works.
Okay, so this brings up a massive real-world problem, right? We've just given our agent all this power. But you know what they say, with great power comes great responsibility. What happens when it decides it wants to do something risky or expensive? Or maybe something you can't undo, like deleting a production database or ordering $1 million worth of supplies? How do we stop that?
Well, the answer is a really clever pattern called long-running operations, or LROs for short. The best way to think about it is that an LRO gives your agent's tools a big red pause button. So the tool can start doing something, then hit pause and wait for an actual human, that's you, to say, yep, go ahead. Once it gets the okay, it picks up exactly where it left off. This is how you build a safe, human-in-the-loop system. It's absolutely crucial.
So let's actually walk through this flow. The user asks for something expensive. The agent calls a tool, and that tool is smart enough to see, whoa, this is a big deal. So at time 6, it hits the brakes, it pauses, and it asks for confirmation. Now the magic here is something the source calls an invocation ID. It's basically a unique bookmark for this exact task. So when a human finally approves it, the system uses that bookmark to find and resume the correct job. There's no confusion, no mix-ups. It's a seamless and safe continuation.
Okay, Chapter 3, adding memory and state. This whole pause and resume thing is fantastic, right? But it immediately creates a new problem for us. If an agent is going to pause a task and come back to it later, well, it has to have a memory. It needs to be able to remember what it was even doing in the first place.
And that's the core problem with the basic agent we built back in Chapter 1. It's stateless, which is just a fancy way of saying it has amnesia. Every single time you talk to it, it's like you're meeting for the first time. It has zero memory of the past. And an agent with no memory, well, there's no way it could handle a workflow that needs to be paused and then resumed later on. It just can't work.
So the solution to this amnesia problem is something called resumability. What we do is we wrap our agent in a special app that basically acts like a memory module for it. This app adds a persistence layer, a way to save stuff, and it saves everything. The entire conversation history, which tools were called, and crucially, the exact spot where it paused. This is the key. This is what finally gives our agent a long-term memory.
All right, on to Chapter 4, Observing Your Agent's Mind. We've come a long way. We've built a pretty sophisticated agent with tools, with memory. It's great. But now we hit the classic engineering problem. What happens when it doesn't work? When it breaks? How in the world are we supposed to look inside its mind and figure out what went wrong? Oh man, I'm sure you've seen this. We've all been there. You give your agent a perfectly reasonable request, and it just comes back with this, "I cannot help with that request." It's so frustrating, and it's the moment every single agent builder dreads, because your immediate thought is always, why? Right? Just why? What happened? Was my prompt bad? Did a tool break? Did an API fail somewhere? See, without a way to peek inside, our agent is just a total black box, and all we can do is stand on the outside and guess, and that's not engineering, that's just frustration.
This is exactly where the 3 pillars of observability save the day. First, you have logs. Logs just tell you what happened at one specific moment in time. Then you have traces, and this is where the real magic is. Traces connect all those individual logs together into a single story, so you can see why a certain result happened. And finally, you have metrics, which give you the 10,000-foot view. How is the agent doing overall? You put these 3 together, and you turn that black box into a glass box. You can see everything.
Okay, let's make this super concrete with a real example from the source material. So the symptom is, the agent says there are like thousands of research papers, which is obviously wrong. So what do? Step 1, we inspect the trace. We can see that a tool called Count Papers was used. Okay, step 2, we look at what was fed into that tool. And bingo, there it is. The root cause is a simple data type mismatch. The code was expecting a list of papers, but it got a single block of text. So it wasn't counting papers, it was counting letters. And once you see that, the fix is immediately obvious. That is the power of having a real debugging process. And here we are, Chapter 5, Agents in the Wild. We've built our agent, we've given it a memory, we even know how to debug it when things go wrong. Now it's time for the final, most exciting stage of the journey, connecting our agent to the rest of the world and going live.
Look, a single agent can't be an expert at everything. The real power, the real magic, happens when they collaborate. And that's where the agent-to-agent protocol, or A2A, comes in. Think of it as a universal language for agents. It's a standard that lets them all talk to each other and use each other's skills, even if they were built by different teams in totally different programming languages running on different servers. It's incredible.
So that brings up a good question. When do you use this powerful A2A thing versus just a simpler local sub-agent? Well, this table lays it out perfectly. The rule of thumb is this. If you're crossing boundaries, we're talking different teams, different code bases, different organizations, maybe even different programming languages, then you absolutely want to use A2A. But if it's all internal, all part of the same project built by your team, yeah, a simpler local sub-agent is probably all you need.
And last but not least, let's talk about actually going live. Deployment. I know this part can feel really daunting, but it's been made so straightforward. You literally just package up your files, your agent code, your requirements, you configure your cloud environment, you run one simple command to deploy the whole thing, and then you test it. That's it. 4 steps and you're live. And just like that, you've done it. Your agent is now live. Think about that. What started as just a script on your laptop is now a real live service running out there on the internet, ready to interact with users. That is a moment of real accomplishment for any builder.
So we've gone on the entire journey, haven't we? From a single, simple script all the way to a globally deployed, intelligent AI system with memory and full observability. You've seen the whole path. You have the map, you have the tools, so now the only real question left, and it's the most exciting one, is what are you going to build next?